Chapter 16. Data Handling. Introduction. Statistics, a branch of mathematics, is the study of collection, organization, presentation and analysis of data, and drawing valid conclusions and making reasonable decisions on the basis of such analysis. Consider the following marks scored by 20 students out of 50 in a class test: 26, 32, 20, 40, 31, 35, 42, 37, 28, 46, 40, 31, 29, 38, 27, 41, 29, 35, 32, 43. Each entry in the above list of marks is a numerical fact, which is called an observation. The collection of observations in the form of numerical figures is known as data. There are two types of data: primary data, secondary data. Primary data, data never gathered before. When an investigator collects the data himself with a definite plan, it is called primary data. Though collection of primary data is a time-consuming process, but it is reliable and relevant as it is original in character. Secondary data, data gathered by another source. The data which is collected by someone other than the user is called secondary data and are obtained from published or unpublished sources. Organization of data. The data obtained in the original form is called raw data or ungrouped data. The data is condensed into groups or classes in order to facilitate the study of their salient features. Such an arrangement is called presentation of data. The raw data can be arranged as follows: ascending order, descending order. The raw data, when arranged in ascending or descending order, is called an array. The marks obtained by 20 students out of 50 are as given below. The data in this form are called raw data. The above raw data in ascending or descending order gives slightly better picture to reach a conclusion. The data is arranged in ascending order as follows. Similarly, it can be arranged in descending order as: if the number of observation is large, then arranging data in ascending or descending order becomes a tedious job. We make a table from 3 columns as shown in the above table. First column is of marks, second for tally marks, and third for number of students, frequency. In marks column, marks are written in ascending order. Now, for each given data, we place a vertical line called tally mark against the marks obtained in first column. We record tally marks in bunches of 5. The fifth tally mark is drawn diagonally across the first 4. For example, is equal to 8. After marking all the observations, we count the number of tally marks corresponding to each observation and write in the frequency column. We find that the sum of all frequencies is equal to the number of observations. Marks, tally marks, number of students: 1, 1, 1, 1, 2, 2, 2, 5, 1, 4, 20. Frequency distribution. The number of times an observation occurs in the given data is called the frequency of the observation. Frequency table or frequency distribution is a method to present raw data in the form from which information can be easily interpreted. Examples. Prepare a frequency table of the following scores obtained by 40 students in a test: 24, 16, 17, 30, 28, 20, 15, 24, 16, 18, 18, 15, 16, 20, 25, 24, 25, 20, 16, 15, 18, 25, 20, 18, 28, 27, 25, 24, 24, 18, 18, 25, 20, 16, 25, 20, 27, 28, 28, 16. Solution. Marks, tally marks. Frequency, number of students. 3, 6, 1, 6, 6, 5, 6, 2, 4, 1, 40. Measures of central value, tendency. We have studied frequency distribution and use of frequency table to interpret the data. The information contained in frequency table can be represented by means of some numerical values. This value represents the entire data. It is a number around which maximum number of observations are clustered and is known as central value of data. There are various methods to find the measures of central value. The most commonly used measures of central value are arithmetic mean, median, mode. Arithmetic mean. Arithmetic mean of a group of observations is defined as arithmetic mean is equal to sum of all observations upon number of observations, or sum of all observation, which is equal to mean into number of observation. The arithmetic mean AM of n observations, x1, x2, x3, x4, x5 up to xn is given by AM is equal to x1 plus x2 plus x3 plus x4 plus x5 up to plus xn upon n. Range. The difference between the highest and the lowest observations is called the range of the given data, or observations. Examples. Find the mean of first 6 even numbers. Solution. First 6 even numbers are 2, 4, 6, 8, 10, 12. Mean is equal to 2 plus 4 plus 6 plus 8 plus 10 plus 12 upon 6. Mean is equal to sum of all observations upon number of observations, which is equal to 42 upon 6, which is equal to 7. Hence, required mean is 7. Example. The mean of 12 numbers is 7. If 2 is added to each number, what will be the new mean? Solution. Mean of 12 numbers is equal to 7. Sum of 12 numbers is equal to 12 into 7, which is equal to 84. Since sum of observations is equal to mean into number of observations, there are 12 numbers. 2 is added to each number. Now, the new sum of 12 numbers is equal to 84 plus 12 into 2, which is equal to 108. New mean is equal to new sum of 12 numbers upon total numbers, which is equal to 108 upon 12, which is equal to 9. Hence, the new mean arithmetic mean of frequency distribution. We have learnt that data can be presented in the form of frequency table, and also the method of finding arithmetic mean of individual observations. In case of huge data, arithmetic mean can be calculated by converting the given data in frequency distribution form. If x1, x2, x3, x4 up to xn are n observations and have corresponding frequencies f1, f2, f3, f4 up to fn respectively, then arithmetic mean AM is equal to f1 into x1 plus f2 into x2 plus f3 into x3 plus fn into xn upon f1 plus f2 plus f3 plus fn, or AM is equal to sigma f1 x1 upon sigma f1, where sigma is a Greek letter showing summation and is called sigma. Steps involved in finding arithmetic mean. Step 1. First column is for value of observations. Second, for the corresponding frequencies. And third, for computing the value of their respective products. Step 2. Fill up the first two columns. Step 3. Multiply the value of observations with corresponding frequencies f1, x1 and write in third column. Step 4. Find the sum of all entries of third column to get sigma f1, x1. Step 5. Find the sum of all entries, frequencies in column 2 to get sigma F1. Step 6. Apply the formula AM is equal to sigma F1 x1 upon sigma F1. Example. Find the mean of the following distribution. X 3, 4, 6, 10, 8. F 2, 2, 3, 1, 3. Solution. X. F into X. 3, 2. 3 into 2 is equal to 6. 4, 2. 4 into 2 is equal to 8. 6, 3. 6 into 3 is equal to 18. 8, 3. 8 into 3 is equal to 24. 10, 1. 10 into 1 is equal to 10. Mean is equal to sigma Fx upon sigma F, which is equal to 66 upon 11, which is equal to 6. Hence, arithmetic mean is 6. Median. In some cases, mean is not an appropriate representation of the given data. In case of mean, the order of the given data is not important, and we need not arrange it in ascending or descending order. But for median, we arrange the data in ascending or descending order, and the middle term gives the median. For example, if there are 7 terms, odd numbers, the middle term will be the 4th term as it divides the arranged data in 2 equal groups. If the number of terms are 8, even numbers, there will be 2 middle terms in arranged data as it divides the data into 2 equal groups. The mean average of these 2 middle terms will give median. The following illustration will make the concept more clear. Examples. Find median of 5, 7, 11, 9, 6, 5, 8. Solution. Therefore, 7-term arranging the data in ascending order. 5, 5, 6. 7, 8, 9, 11. Middle term is equal to 4th term, which is equal to 7. Hence, median is 7. Example. Find median of 4, 5, 7, 11, 9, 6, 5, 8. Solution. There are 8 even terms. Arranging the data in ascending order. 4, 5, 5, 6, 7 middle terms. 8, 9, 11. Median. Average of middle terms, which is equal to 6 plus 7 upon 2, which is equal to 6.5. Hence, median is 6.5. Median is the middle value after the observations have been arranged in ascending or descending order. We can calculate median as under when n is odd. Median is equal to value of n plus 1 upon 2. Th term. When n is even, median, which is equal to value of 1 upon 2 into n upon 2 th term plus n upon 2 plus 1 th term. Example. Find the median of the values 14, 18, 15, 20, 35, 25, 30. Solution. Arranging the numbers in ascending order. Number of terms n equal to 7 odd. Median equal to n plus 1 upon 2 th term, which is equal to 7 plus 1 upon 2 th term, which is equal to 4th term. The 4th term is 20. Hence, median is 20. Example. Find the median of the values 15, 10, 18, 25, 20, 30. Solution. Arranging in ascending order. 10, 15, 18, 20, 25, 30. Number of terms n is equal to 6 even. Median is equal to half n upon 2 th term plus n upon 2 plus 1 th term, which is equal to half 6 upon 2 th term plus 6 upon 2 plus 1 th term. which is equal to half third term plus fourth term, which is equal to half 18 plus 20, which is equal to half into 38, which is equal to 19. Hence, median is 19. Mode. Mode is the value of the observation for which the frequency is maximum. In other words, the observation which occurs maximum times is called mode. Examples. Find out the value of the mode from the following data: 50, 40, 50, 70, 50, 80, 40, 70, 50, 52, 45, 50. Solution. For finding out mode, we make frequency table, observations, tally marks, frequency, 2, 1, 5, 1, 2, 1. Since the value of 50 is repeating maximum number of times, that is 5, therefore mode is 50. Bar graphs. We have learnt to present the data in the frequency distribution form. The data is presented in various forms. Bar graph is one of the forms. A bar graph is a pictorial presentation of numerical data in the form of rectangles or bars of equal widths and varying height. These bars are drawn either vertically or horizontally. Construction of bar graphs. Step 1. On a graph paper, draw a horizontal line OX called x-axis and draw a vertical line OY called y-axis. Step 2. Along the horizontal axis, mark points at equal intervals. Below these points, the names of the data items like days, weeks, months, year, etc. are marked at uniform gaps. Step 3. Choose a suitable scale to determine the heights of rectangles and then mark the heights on y-axis. Step 4. Draw bars or rectangles of equal widths on the horizontal axis with equal spacing between them. The bars represent the numerical data. Examples. In the following table, the details of rainfall in a city from May to September during a particular year is given. Construct a bar graph showing the data. Month: May, June, July, August, September. Rainfall in centimeters: 20, 30, 25, 20, 10. Solution. Working steps. We draw two lines perpendicular to each other on graph paper and mark them as OX and OY, horizontal and vertical axis respectively. Along OX line, we mark months, and along OY line we mark rainfall in centimeters. We choose a suitable scale to determine the heights of the bar. Here, we choose 1 square centimeter as 5 units. We draw the bar leaving uniform space between bars as shown. Probability. In our daily life, when we are not sure of happening an event, we use the word probably. Examples. Probably today will be a hot day. Probably India may win the cricket match. Chances of his getting distinction are bright. The word probably, possible, chances, etc. convey uncertainty about the occurrence of some particular event. In statistics, we have methods for calculating the degree of certainty of events in numerical values under some given conditions. Some definitions. Experiment. An activity which has some well-defined results is called an experiment. Outcome. The result obtained from an experiment is called an outcome. Trial. A trial is an action which results in one or several outcomes. If we toss a coin, then its outcome is head or tail. If we throw a dice, there are 6 possible outcomes: 1, 2, 3, 4, 5, or 6. Random experiment. An experiment in which the result of a trial cannot be predicted in advance is called a random experiment. The tossing of a coin or throwing a dice are random experiments, since the outcomes cannot be predicted. Event. An event is a collection of some outcomes of the experiment. In other words, the possible outcomes of a trial are known as events. Sample space, the collection of all possible outcomes of an experiment, forms its sample space. When a dice is thrown, then sample space denoted by S is equal to 1, 2, 3, 4, 5, 6. Similarly, when a coin is tossed, its sample space S is equal to HT. Definition of probability. The probability of an event is the ratio of number of favorable outcomes to the number of total outcomes. Probability of an event is equal to number of favorable outcomes upon number of total outcomes. Possible outcome of an experiment. Tossing a coin. If we toss a coin and let it fall freely on the ground, it will rest on the ground with one of its faces upward. It will show either head or tail. Thus, the possible outcomes are head or tail, that is HT. Tossing two coins. In case of throwing two coins, there are four possible outcomes: two heads, two tails, head on first throw and tail on second, tail on first throw and head on second, that is HH, HT, TH, TT. Throwing of a dice. A dice is a solid cube having 6 faces, and each face is a square. The 6 faces are marked as 1, 2, 3, 4, 5, and 6 respectively. If we throw a dice, there are 6 possible outcomes on the top face. Note: probability of an event lies between 0 and 1. Probability of an impossible event is 0, and probability of an event which is certain is 1. Example: a dice is thrown once. What is the probability of getting a number 3? Solution: required probability P 3 is equal to number of favorable outcomes upon total possible outcomes, which is equal to 1 upon 6. An even number. Solution: total possible outcomes is equal to 6. Even numbers is equal to 2, 4, 6. Probability, even number, number of favorable outcomes upon total possible outcomes is equal to 3 upon 6, which is equal to 1 upon 2. An even number and a multiple of 3. Solution: an even number and multiple of 3, that is 6. P, an even number and multiple of 3, which is equal to 1 upon 6. Example: one card is drawn from a well-shuffled deck of 52 cards. What is the probability of drawing an ace? Solution: total number of possible outcomes is equal to 52 because any one out of 52 cards can be drawn. Since number of aces in the deck are 4, so the possible outcomes are equal to 4. P, drawing an ace is equal to favorable cases upon total outcomes, which is equal to 4 upon 52, which is equal to 1 upon 13. A face card. Total number of possible outcomes is equal to 52. Total number of face cards is equal to 4 king plus 4 queen plus 4 jack, which is equal to 12. P, a face card is equal to favorable outcomes upon total possible outcomes. P, a face card is equal to 12 upon 52, which is equal to 3 upon 13. Example: if probability of winning a game is 0.4, what is the probability of losing it? Solution: probability of winning a game, P, is equal to 0.4. Probability of losing it is equal to Q. Let probability of losing a game plus probability of winning a game is equal to 1. That is, P plus Q is equal to 1. 0.4 plus Q is equal to 1. This implies Q is equal to 1 minus 0.4. This implies Q is equal to 0.6. Thus, probability of losing a game is 0.6.